Hello, everyone, and welcome to Parity and Friends. I am Caroline, and I'm your host for today. Today, we have two great talks coming up. First off, we have Kian from Parity Technologies, one of our core developers, and he's going to be talking about Polkadot's nominated proof of stake system. And then he will be followed by Hoon from Plasm Network, presenting the future of XVM cross virtual machine on Plasm Network. Yes, so it should be a great event, a lot of interesting things. We will have time for Q&A at the end of each of the presentations. So you can see at the bottom of the screen the Ask a Question feature. Submit any questions you have during the talk. And you can upvote anyone that you want to hear answered. I'm sure we'll have time to hear all questions that are submitted. And I will ask both of them at the end of their presentations. As you can see, we have the open troll box here. If you have any issues during the event where the slides aren't moving, or you might have sound issues, I see some of you having some issues right now, just refresh your browser and it should work fine. Just a little bit of troubleshooting there on the fly. So without further ado, I would love to hand it over to Kian to get started on the nominated proof of stake system. All right, take it away, Kian.
Yeah, thanks, Caroline. So, hi, everyone. I'm Kian from Parity, and I'll be talking about the NPoS of Polkadot. Before I almost forget, share my screen. Shout out if it's not visible, it should be. So yeah, the title is Polkadot's nominated proof of stake: the past, the present, and the future. And I would like to go over how this system evolved over time, and it will be a little bit of history, not too much technical, and also give like a brief overview of what are the upcoming features. So yeah, the agenda is, aside from the past, present, and the future of the system, to also explain at the beginning a little bit of the fundamentals of why we have nominated proof of stake, how it's different, and why it's important. So without further ado, let's begin with that. And I would like to bring your attention to this schematic that should be fairly familiar to all of you, of how a parachain should work, because this concept is really fundamentally interlinked with Polkadot and what Polkadot wants to achieve, which is to secure parachains. And taking that into perspective and looking a little bit in more detail into that, a parachain block is always executed by a number of validators from the relay chain. So the important point is that taking into account that Polkadot's main purpose, let's say, is to secure, make sure that a number of parachains function properly. The state transition of these parachains always happen on the validators of the relay chain, not the parachain collator itself. Of course, the parachain collator itself should also have the state transition function, in which case this is a WebAssembly blob. But where it's verified and where the final outcome is determined, it's in the relay chain validators. So it's really critical for the validators of the relay chain to have a lot of economic security behind it. I'm just realizing this sun is kind of making me look like Jesus, but I hope it doesn't get worse than this. Yeah, so within this context, just comparing the collator of the parachain and the validator of the relay chain, the significance of how important it is for them to be secure economically is really important, and the weight is strongly on the side of the relay chain. Like, we want the validators of the relay chain to be really secure, like as difficult as it can be to become a validator, as expensive as it need to be, because the more expensive it is to become a validator, the less the likelihood of any compromise would be. So this is like the intro of why we need NPoS in the first place. So let me first address the first title, that the collators, it's not like the collators don't matter at all. I don't want to give that impression, just make a small correction that they need to be to some extent, of course, secure. They can never cause a incorrect state transition because the state transition happens in the relay chain, but they can, for example, censor certain transactions or simply just cause the parachain to kind of stall or go dead temporarily. So they can be annoying, but yeah, the weight is still, the importance is still on the relay chain side. And the second point, this is really the fundamental guarantee of Polkadot, that it's a shared security system between all the parachains. So if the relay chain is really secure, all the parachains have the same degree of security. And this is also very important when they interact with each other. And this is fundamentally different from another multi-chain, let's say, paradigm, where each relay chain needs to bring in its own validator set and then therefore have its own security guarantees. And this just makes everything significantly different. Like when you want to send a message from one parachain to another one, you need to look into what is the security model of the other parachain, how many validators does it have, how much stake do they have behind them, how does it work? But whereas with Polkadot, it's a shared security. So again, emphasizing that the Polkadot validators have a really important role. It's much more than just being the block authors of the relay chain. It's essentially being the block verifier of all the parachains, which is much more. Yeah, and this is why Polkadot is sort of willing to at least experiment with the idea of spending a lot more effort into how validators are elected or selected, yeah, how we decide who would be the next validator set for the next era. I mean, yeah, the era is a fixed term in Polkadot where validators typically don't change. But yeah, generally speaking, how we choose our validators, Polkadot is really keen on that, let's say. Okay, and now let's look into somewhat similar systems. I have this phrase here, like EPOS. There's a lot of like something POS out there, and I'm not really familiar with all of them. I didn't really want to name anything to make a false comparison, but let's just call some E for easy POS. Which is where you as a nominator, like you back one validator, so you name one of them. And if that validator happens to be a winner, like if the active validator, then all of your stake backs them. And typically in these systems, your stake is also liquid, meaning you can always take it back. It's like the validator is already selected. You just kind of give them an extra bit of backing stake. You can also make this a little bit nicer. I'll call it like glorified easy proof of stake, where you can name multiple accounts when you want to vote as a nominator. And if, I don't know, 5 of them get elected, then your stake is divided between those 5, 1/5 each. And there could be more systems here, like in this step number 3, where, as I said, I don't want to name too many things, but I think the end of this spectrum would be NPoS, or what Polkadot is trying to do, where you just name a bunch of validators as a nominator, as people that you wish to back, and an algorithm decides how your stake should be distributed between them to achieve certain security guarantees, to optimize certain criteria in the system that I'll get to. And in this system, nomination is a more critical task as well. Your stake is most often, not only in Polkadot, I believe in some other similar systems as well, your stake as a nominator is subject to slash and of course reward as well, but you can also get slash. So it's no longer like that liquid staking where you just, put something there, there's no risk. No, it's just like a more important thing to do. And let's talk about like this algorithm that optimizes certain things a little bit. So looking at this NPoS system, which is like NPoS problem, let's call it, which is that we have a bunch of nominators and a bunch of validators, and there is like a graph form in between them, where nominators, or aka voters, name a bunch of validators that they wish to back. And the output of this NPoS algorithm should name which of these validators are the winners, or should be the winners, and how much stake from each of the nominators that back them should be given to each of the winners. So I mean, in this case, there's like only one. Actually, I just realized it's like a not was yeah. Okay, this graph is not a good example. Actually, I just realized it. But hypothetically, if one of these nominators had backed like 2 of the winners, then the question would have been, what should X, Y, and Z be? I mean, in this case, it's a little bit trivial because these 2 nominators who have 2 votes, one of them is pointing to an active one. But yeah, okay, yeah. Assume that you as a nominator have voted for 3 validators. All 3 of them have been elected, or should be elected. Now the question is how your stake should be distributed between them. And we typically optimize for 3 factors. Like this is something which has sort of been standardized in Polkadot by the Web3 Foundation as the objectives of the NPoS. And that's to the minimum backing stake among all validators. So the weakest of the validators, whoever that is, the stake of that min validator should be maximized. So this is basically like the entry barrier to the validator set. We want the minimum validator to be really expensive, meaning that if a malicious validator wants to come to the set, they must beat this minimum validator, so they must have more stake, and if this threshold is higher, therefore it's harder to get into the validator set as a malicious validator. We also want to maximize the total amount of stake, and the third objective, we want to minimize the variance of the stake. So we want to have a lot of tokens at stake, but we want the minimum of the validators to be certainly high, but we want the maximum to also be relatively close to it. So we want to have like a very evenly distributed validator set. These 3 are like the objectives of this algorithm that should solve the NPoS problem. As you know, in Polkadot we have an algorithm, or some of you might know, we use an algorithm called sequential fragment. I'll get to it, but what I want to do next is just explain or just have like a quantitative, like a numeric example saying why, so just pointing out the difference here. So these numbers, I got them from a few hours ago. Like every day on Polkadot, the election for the next day of validator happens around 1:30 p.m. in Central Europe time. And the numbers that I have here, and I just kind of like hacked together a small tool that would get the inputs of the election and would calculate the result in a sort of like DPoS style, or the easy EPoS style, where all the voters, if they have voted, or all the nominators, if they have nominated like 5 validators, it's almost as if they have backed each of them by 1/5. So this is like the typical like easy proof of stake type of election. And I have like the first 2 objectives of quality of the solution that I just mentioned in the previous slide. I recorded these 2. So when I did this calculation for today's live Polkadot status, the first element of the score, like the first element of the array, was about 11 million dots. Like the weakest validator that was elected by this DPoS style election had this much stake backing them. And the total amount of stake dots that were stake was about 5.9 billion dots. These numbers also kind of add up. I mean, the total issuance of DOT is 10 billion, and yeah, so it's definite. I was trying to sense check it for myself, but they add up. And the actual validator set that was elected through some mechanism that we will get to today in Polkadot by the chain, which is much more optimized. It's much more difficult to compute, but it's also much more optimized than this DPoS. Came up with this score, which is the score of the validator set, which is literally active right now in Polkadot. And the minimum validator of Polkadot right now has 17 million dots backing them. And the total amount of dots that are staked is almost 7 billion. So I want to really like point out that this is about 6 million dots difference like the minimum validator stake, which in some sense is like the threshold to compromise the system. So the threshold to compromise Polkadot through gaining a validator right now, because of the complication of NPoS, is about the dollar equivalent worth of 6 million dots more difficult to achieve. Compared to if Polkadot had implemented that easy POS that I mentioned, like where election was like that simple, everything would have been much easier in some way. But yeah, the security measures would be much lower. And again, to recap, why we're doing this, parachains, or the model of Polkadot, where the validator set needs to be like really super duper secure. The difference in the second score metric is also quite a lot, about 1 billion extra dots, which is staked. Because yeah, we optimize for these objectives. So yeah, now let's. This was like the intro of why we do NPoS, why it's difficult, and why it's worth it, basically. Let's look at the past and how we did this. So we had the selection algorithm, sequential fragment. In the very old past days, it was like just like YOLO. We ran it on chain. It was like the early days of the testnets of Polkadot, or the early days of Kusama post-Genesis, where there were like, I don't know, tens of validators and hundreds of nominators, and it all worked really well. Until we realized that, yeah, you can't run a algorithm that solves an NP-hard problem on-chain, because it's quite difficult. And the observation or the plan was to leverage the fact that it's much easier to verify any external solution to this NPoS problem rather than compute it. So we thought, okay, we're going to offload the work to some off-chain entity and only verify it on-chain. And this brings us to the old off-chain fragment model, which was also talked about, I think, about a year and a half ago in some Sub-Zero events, I believe, where the pallet staking, which lives in Substrate and is being used in Polkadot, had a mechanism where at the end of the era, off-chain workers would start to compute the election result and submit it back to the chain as a transaction. And if yeah, and this had some drawbacks. For example, during this period, which was usually like an hour or so, no one could nominate, no one could interact with the staking system, because an election was ongoing and we didn't want to change the data in the meantime. It had a backup system where if this election system for whatever reason failed, then we would run on-chain election, which would mean there would be like usually a very expensive block, but it didn't happen that frequent. And all of this was rather inefficient, sort of weight-wise, in terms of like yeah, efficiency, which led to the fact that Polkadot until recently had to sort of trim the election solution when it was being submitted back to the chain in order to make it fit into the block, which was the reason that the number of nominators was effectively limited on Polkadot until recently. But this brings us to the present, which, and we quite recently, all of this was refactored. I won't dive into too much of this, also in favor of time. There's now a whole new palette that does one thing, but does it much better. And it's called like a multi-phase election provider palette. Lives next to staking. Staking no longer takes care of like all this election stuff itself. And yeah, I would say like the TLDR, all of this is that it made everything much more efficient and yeah, much more efficient. And most notably, we are in the midst of getting rid of that on-chain backup election, because imagining Polkadot having like, I don't know, 50,000 nominators, 100,000 nominators, running the election on chain is just suicide. The chain is gonna like not survive that. So there's like a new emergency system now in place where if the election system for whatever reason fails, the governance can intervene and fix it, and or say, okay, you know, there's an issue in the system, temporarily this validator set would be used. And all of this led to the fact that since recently, when all of this new code was deployed, the number of nominators in Polkadot was increased significantly. Like a lot of more people that were sort of like on the waiting list managed to get in. This is a graph from like some internal tool, but I guess anyone can like sort of check it out, or there are some public equivalents as well. On a certain date, we jumped from like having like 7,000 active nominators to like about 17,000, and still growing. Although it's worth mentioning that this increase in itself caused sort of the system to grow in ways that we had not unforeseen. Like most notably, we always look at weight usually, which is like substrate's equivalent of gas. Like just yeah, just in terms of terminology, they're not really similar. But yeah, we generally focus on weight, but there was like an out of memory issue that we didn't foresee, and it kind of led to that, I think 2 Mondays ago, where Polkadot was sort of down for a few hours. I just coined it while making these slides, the Black Monday of Polkadot. Yeah, there's a great postmortem for it on the Polkadot blog of why it happened. And yeah, a brief recap on like the present and the imminent things that would happen, the current state of affairs. So one new feature of this multi-phase election, this individual election palette that we have deployed, and we're going to just keep improving, is that it's going to allow solutions to come from any account. And this is something important that I wanted to at least bring up today. That there would be like a small opportunity for running off-chain miners in some way, miners that find solutions to NPoS and then submit them to the chain and get a small reward for it. Of course, it's still very near being done, but I mean, I already put it under present because I think it's imminent. It would be merged and deployed very soon. So this is like I think a new addition, like this signed phase where anyone can basically provide the solution to the next validator set of Polkadot. And if it's valid, and if it's a good one, we reward them. If it's a bad one, we slash them. And we're also working on like a template miner binary, which would live in the Polkadot repo probably. But I believe if the monetary incentives are good, I think the community would probably beat us and make better miners over time. I mean, we have to see about that. I also mentioned the governance backup solution. I'm going to skip that because I realize I'm a little bit short on time. And yeah, with the current numbers, I'm going to like just make a rough estimate based on some metrics. I think we're pretty much good to go up until around 50,000 nominators, and afterwards we have to rethink again, or reevaluate again, or we would just bound it at this number and think again about what's going to happen. Because all of this is really like, yeah, we're doing like very complex stuff on chain in a like decentralized, trustless manner. But yeah, there are some implications. I'll get to that in the next section, which is the future. Yeah, so but this 50,000 is like my current sort of estimate of how long we can stretch the current system. But I mean, as we're going closer to 50,000 nominators, we're also working on new systems. So maybe this time we can beat it, and there would be no limitations, but we have to see. And finally, the future. So a lot of what we're doing is, as I said, it's literally like solving an NP hard problem on chain. It's like ridiculously hard, and like ridiculously, I would say, out of context. Like typically blockchains are meant to do very little, but do like little amounts of work that's critical. But in this case, we have to make a compromise. Although we're already doing like the solution computation off chain, but we eventually need to verify it on chain because otherwise it wouldn't be secure. Yeah, securing it itself, and even though it's not NP hard, but it's still damn expensive. And this is going to push us toward researching and thinking more about how to do multi-block computation. This is something that we still haven't done anywhere like in the wild, but there are like pull requests for it in Substrate. There are lots of discussion on it on the Substrate sort of channels. And I think it's a very interesting field to explore. A slightly more long-term plan, or utopian plan, I would say, is to have like a election provider common good parachain living in Polkadot. This is also something that, yeah, we have to see if it will be feasible, but if so, we would definitely do it, or try doing it at least, because it really makes sense. So there would be like one common good parachain that would only take care of providing the election, this NPoS election functionality to the staking. And probably the staking functionality itself would stay on the relay chain, but the election, all the computation would happen in a separate parachain, and only the results will be feeded back. And yeah, as I mentioned, probably if we don't, like, by the time we move the election stuff either to multi-block or parachain, which would be like the good scaling solutions, there's an extent to which we can sort of like stretch the current system. So we might need to at some point rethink how we're doing staking, and put some different bounds, make it multi-layer maybe. Like some people would be nominator, but being a nominator would be more privileged. You need to have a certain amount of stake, but then you can be a delegator of that nominator. You have to think about it. But yeah, to sort of look at it realistically, you can't scale the number of nominators infinitely and expect it all to work. So we have to see where that takes us. It's definitely a journey that we're doing, learning on the way. Yeah, that brings me to my conclusion. As I said, we're truly doing something that has a lot of value because of the explanations I gave at the beginning and also the numerical example. I'm pretty glad that I did that today and I put it in the slide, because it also kind of proves to some extent that it's not all in vain. Like it is really valuable to Polkadot to go through all these efforts and all this risks, let's say, of all this complex code existing in it. But it's worth it, but it's also to a high extent sort of unprecedented. So we're really like pushing the boundaries of what's possible and what can be done in a decentralized way. Yeah, I think changes are expected to happen within the system fast. So if you're interested, definitely tune into like the Polkadot and Substrate newsletters or GitHub. But for now, I think the most interesting thing for the community that's going to come out is the concept of a staking miner, and the fact that it would be possible for anyone to build a miner that would compute a solution to this NPoS situation that I just explained, submit it to the chain. If it's a good one, get a reward. If it's a bad one, risk it. So that's I think the most important, or the most short-term interesting thing that's going to happen. But yeah, if you ask me, it's going to be the same in 6 months, I'll probably say no. Like in 6 months, probably lots of things need to be changed again. Also because the Polkadot is also growing quite fast. Like especially now with the number of nominators, we're growing like, yeah, we're just constantly going up. So we have to see where that takes us. Yeah, this FAQ section is not important. It's just some things that I didn't mention, and if they don't come up, I'm not going to mention them. Unfortunately, I forgot to prepare a link to the slide, but we will later hopefully put it in, I think, the description of the YouTube video, which would contain this talk. So yeah, with that, I'm happy to, well, I think I almost ate all of my Q&A time, but yeah, Caroline, if any questions or anything I can answer, I'm happy to take that now.
Yeah, you have a little bit of time left, so it should be fine. So first question we have is, doesn't the nomination lead to centralization?
Let me open that myself. Doesn't the nomination lead to centralization? I don't understand. I don't agree why. Maybe whoever posted that can bring a little bit more context to it. So nomination is basically you sharing you basically diluting yourself into a validator and saying whatever they earn, I earn with them. Whatever they lose, I lose with them. And with that, we're basically just increasing the security threshold of the system. And I think if it does anything, it does the opposite, which is like, okay, I mean, this is about centralization, not security. No, I don't see that. I mean, to some extent, Polkadot needs to gather a hefty amount of stake in its validator in order to keep them secure. So I don't know if that's the definition of centralization, then yes, but other than that, no.
Okay, so next one, the most secure validator set. What does that mean?
Yeah, so I think maybe it was answered throughout the talk. Current metrics that we are looking at is a validator set that optimizes these 3 metrics. Like basically, the better you are with these 3 metrics, the more secure you are. Of course, this is like a detail of the protocol, and like anything else, is something which is easily subject to change. But I haven't heard anyone make a better proposal. But yeah, it's something that hypothetically, for example, someday the governance of Polkadot can decide, okay, no, this metric is better, or let's tweak this metric in a different way, or let's like give this 3 objectives, different weights. Yeah, it's possible, but the current metric is these 3 items.
Cool. And then the last question we have is, will the 28 days of redeem change?
Not likely in itself, but it's something that is possible to discuss. Again, I would say it's a community question, and it's not in my power to change it, so I don't have an answer to that either. I guess there are good reasons for it to be there. I can just say that. And I can also add that if it needs to change, certain other parameters also need to change, but it's something that the chain can itself decide to change if it wants to. Like Kusama already has a shorter, and because it has lower security guarantees, possibly. So yeah, that's.
Okay, 2 more questions just came in.
Yeah.
So where can I find the off-chain worker to verify scores?
So currently it's in a palette in Substrate called Palette Election Provider Multiphase. I will add it to the links I will link it somewhere in the slides, and once you have the slides, you can find the link there. Like all the election-related code now lives within one palette, which makes it also easier to find, easier to read, easier to understand, and everything.
Okay, and then the last one is quite a big one. It feels like how we can allow miner to propose solutions to the NP hard problems as ineffectively as possible, since they just need to send the solution somehow. And the verifier just has to be efficient. Sounds very similar to the setup of interactive proofs between efficient verifiers and ineffective provers proposing challenges taken to each other. Is there some relation of Polkadot's method of potentially outsourcing the NP hard problem with interactive proofs IP?
Yeah, okay. I was reading it as well, so I could follow. Interesting point, but not that I know of. Not really my field, like interactive proofs. Yeah, not something that I'm very familiar with. So not that I know of, but I'll write it. I will make a note maybe to look into it. But the description was the description was like correct though. Like the miner is free to like basically run any algorithm it wants. This is the assumption that we have. Like the official off-chain workers that ship with Polkadot nodes run a certain algorithm that is hard-coded in the WebAssembly blob, namely the sequential fragment that I mentioned. But the miner is basically free to do whatever it wants, and as long as it's willing to like prove that its solution is valid and it's good enough, they can submit it. I don't know if that adds anything to your context, but otherwise the question itself, unfortunately, I don't know much about it.
Great. Well, that was all of our questions. Thank you so much, Kian. That was a great presentation.
My pleasure. Thank you, everyone.
Yeah, great. Next up, I would like to invite Hoon on stage. Hi, Hoon.
Hello.
Great. Are you ready to go?
Yep, ready. I'll share my screen.
Great. I'll let you take it from here. Thanks, Hoon.
Thank you. Okay, hello everyone. Other side of the world here. So today, I'll be talking about what we call XVM in Plasm ecosystem. So for what XVM or a cross virtual machine is, think of this presentation as more of a high level view of what we think is more valuable for blockchain technology to move forward, and what is required for people to create more decentralized applications on blockchains, and how we're trying to achieve that, and our future directions, and what sort of characteristics Plasm Network and Shielded Network has compared to other parachains. This is today's agenda. So first, we'll start with the value for blockchains, or at least what we think is more valuable for blockchains. Characteristics of Plasm Network. Talk about the barrier of entry when it comes to developing dApps, and what the future holds. Next, we'll talk about our vision of becoming a hub for smart contracts or dApps within the Polkadot network. And finally, we'll end it off with our future for what we call XVM. And is this word XVM well explained soon? For now, before we go into the details for smart contracts and virtual machines, let's talk about the high-level purpose of a blockchain. So, of course, this is different from network to network, to person to person. But at least for us, we think blockchain has real value from its applications. And of course, a value of a blockchain can be measured by the value of the cryptocurrency or its market cap. But to us, you can't really, what's the point of having money if you can't really spend it on something? And that's what we think blockchain is so strong, because it's able to create this new paradigm called decentralized applications, which has the ability to to verifiably empower the user. What I mean by verifiably empowering them is, think of it this way. Let's imagine there's a system where you can log into different applications, use different services, make payments with one account. And that would be pretty awesome, right? It's already a thing, which is called login with Google or Facebook, or pay with PayPal. And it's also what OAuth 2.0 is in a nutshell. But the problem with those authentication systems is that it relies on the centralized system for-profit entity to not mess up, which I hope that doesn't happen. The thing is, we can't. It's out of our control. So that's why we want the users to carry the private key themselves to have direct authentication and being able to identify an account across different applications. And that's what we think is one of the strengths of a decentralized applications to the general public. And this dApps, a dApp is created through call a smart contract, which is a way to express an exchange of value or sending a message between multiple accounts within a blockchain. So for smart contracts to work, a blockchain must have a contract engine, which is also referred to as a virtual machine. I think of it as an EVM or Ethereum virtual machine for running Solidity bytecode. But or even bytecode, sorry. Yeah. Now, this itself was it was quite eye-opening when Ethereum was getting big. Being able to call a contract from another contract is amazing, but there are a lot of issues when it comes to scalability, or gas prices, or even just using it for business cases or business use cases, or for production. But then with Polkadot Network and other ways to create bridges between different blockchains, we're seeing an emergence, sort of an increase in interoperable blockchains, and seeing more people having more interest, and people understanding why interoperable blockchains are awesome. So unlike the blockchains of yesterday, blockchains of tomorrow, instead of being a linear chain of blocks, it's more of a web of chains. That's how I like to call it. And when you're trying to create an application that is interoperable, there are two options. One is to create a custom blockchain from scratch, or you can fork an existing blockchain. And thanks to Substrate, it's developing a blockchain is much more easier and scalable, but it still takes a lot of time, and your access to other networks are quite limited, since you have to directly implement the bridge contract to your network. The other option is to deploy a smart contract on a parachain. So by deploying a smart contract, be able to access XCMP, which passes a message between a parachain to another parachain by a relay chain from the parachain Polkadot network, and it is much more scalable and affordable for people who are trying to make a business out of this, especially when the network offers layer 2 scalability solutions. So let's talk about what makes Plasm Network unique compared to other blockchains within the Polkadot ecosystem. For one, we have this built-in reward system called dApps staking, and it's similar to proof of stake in terms of reward distribution, but instead of distributing rewards to a node or a validator, we split the block reward by half, and give that to the controller and the nominator for a smart contract. So in a sense, you are directly investing in a application on Plasm Network. The other characteristics we have, or I guess the other feature that we have, is layer 2 support. We support optimistic virtual machines to act as like an adjudication layer when exiting funds from a child chain to the root chain. We also started work on ZK rollup, or zero knowledge rollup, which has a more deterministic security when communicating with a root chain from child chain. The other feature is the environment of supporting multiple virtual machines or smart contract engines. Right now, Plasm Network supports the EVM provided by the Frontier library, and Ink, which is the core default smart contract engine, works with WebAssembly natively, so it's very efficient. And this is where the concept of XVM comes in, as we want to be able to make smart contracts interoperable between different engines. So let's talk about the WASM-based smart contracts, specifically Ink and the contract palette in Substrate. Now, WASM or WebAssembly-based smart contracts are very, very awesome. They are very efficient. It is very portable, so it's not limited to the browser, but it can work with pretty much any systems if you can manage to implement the WebAssembly system interface for it. Then it really extends the possibilities, the capabilities of what a smart contract can do. For Substrate-based blockchains, it has native support, and we can see more growth to this since Ink is rapidly growing. More and more blockchains are, specifically Substrate-based blockchains, are implementing this, and there'll be more features added onto it. So you can see that WASM has a bright future. But okay, yeah, it's all good. But where can you start? And the thing is, documentations for Substrate is great. So Substrate developer GitHub is beautiful. The content is great, but there are some documentation that's not really updated frequently. And you can see here, this is the official documentation for the contract section in Polkadot client side, for the Polkadot client side library. And you can see the latest update is like 3 months ago, and the contract module itself is updated constantly, both in the palette side and the client side as well. If you look at the Polkadot API, it has a release like every hour, but the documentation cannot catch up. And for people who are coming into this concept of decentralized applications or blockchains or smart contracts, for them, it's very overwhelming. Where should they start? Most people might have heard of Ethereum. And the ecosystem is very big. There are rich documentation, a lot of video tutorials on YouTube. And here you can see even the community, Ethereum, the subreddit r/Ethereum is like almost 1 million members. While Polkadot and the r/dot, which is the unofficial subreddit for Polkadot, is trying to go for 40K, and Substrate it's like 600 members. This is because for now, it's a lot of people who are developing new technology are interested in Polkadot Network, building on Substrate. But people who are trying to create an application that uses blockchain technology, it's just not enough. The ecosystem for EVM-based contracts are still very big, and it is still growing. Of course, when it comes to performance, WASM-based contracts, even in Ink as well, it's far superior. But when people are just entering the development, they don't care too much about how much performance it can make. They want to know where it can start. And that's why we think EVM as the contract execution model in Ethereum and in Plasm Network and in any other network, in Hyperledger, it's an environment of the past, something that is still relevant today. It's the popular kid in school because everyone knows about it, everyone loves it or hate it, but still everyone heard about it. At the same time, the standards, documentation, resource, all the tools are made for EVM-based contracts will stay as it is, and it will most likely act as a gateway for new developers. So that is why we think it's important for us to be able to support Ethereum based or EVM based contracts, and yet we still want people to migrate, move to the future with us. We don't want to limit developers' options. So that is why we came up with this feature called XVM, or Cross Virtual Machine. Now, our vision of XVM is to provide a layer of abstraction for dApps. And because for the end user who's interacting with an application, they don't really need to know the details of what hashing algorithm an account uses or what transaction hash it's recorded in. Maybe it is important for development, but for the user experience, it's not the detailed scheme of it. It's not that important. All they really need to know is what events did it emit, what calls can I execute, and what storage can I read. This is common for any smart contracts, regardless of its environment, its language. And that is why we want Plasm Network as a parachain within Polkadot Network to offer that. So even if other blockchains or even other parachains, the Polkadot Network specializes in a certain smart contract, projects that are deployed to that network are able to access other networks or other applications through Plasm Network, as we want to be the hub for all the apps. And traditionally, being able to support different contract engines was something that wasn't. I mean, it's still not easy, but the biggest limitation would be both the performance and trying to control the gas costs. And the gas cost is especially a huge problem for the developers and the users. But because Plasm Network implements layer 2 solutions, most of the heavy lifting will be done off-chain, and it'll be bundled as a single transaction. So the final transaction fee shouldn't be that huge. In fact, it shouldn't be much of a concern at all, since it's just a single transaction in the end. So that is why I think XVM, or being able to cross-reference different smart contract environments, became much more possible, especially thanks to the shared consensus offered by the Polkadot Network. Now, parachains are able to focus on offering their features, not be specialized in being able to be a platform first before being trying to wrap their head around incentivizing the validators. Now, this is a proof of concept implementation developed by our lead developer, Alexander. And this shows what we think what we want to do with XVM. So, and by the way, this is an actual implementation here. So this here you can see a smart contract in Ink deployed. It's a simple contract with a single method, which is just hello. It's a simple function. You execute it and it emits an event. And this is all in Ink. Now you can see the event is emitted. Now what we did is, as our starting point for implementing XVM, we use the precompiled contract, which is an EVM, and create a precompiled contract of the contract palette call within for substrate. So here you can see this is the interface. This is the Solidity interface for the precompiled contract. You can see there's not sure if you can see this clearly, but it has one function, call. The parameters are first one is the destination. The next one is the call data. Destination is the destination contract. Call data is the parameters for that smart contract. Here, see, we have copied the contract address within Plasm Network, and then we got to inspect keys to get the public key. The public key for the address. It's in hexadecimal instead of SS58 coded. And what we do is we use that public key of the address as the destination. You see, we're loading the contract from the address here. So the first parameter is the address of the contract that we want to call. And we just put an empty parameter because the method doesn't take any parameters. We execute the transaction through MetaMask, since this is a EVM call. So what we're doing here essentially is we're calling a ink contract from Solidity, and the transaction has been confirmed. If you go to the Explorer, you can see both the event for the contract has been emitted as well, and the Ethereum event is displayed here too, both in the same block. And, yep, see, everything worked well. And this is how we want to approach the future of cross virtual machines. And for our future plan, we see XVM as a very long-term project. We can't really do this as a single runtime module. So at the start, we want to create another POC module for calling Ethereum or Solidity contracts in EVM environments within Ink. We want to expand that, being able to call some complex contract calls, like ERC20 perhaps. Being able to create a dedicated UI to be able so that people can interact with different smart contracts in different environments without any problem. And in the end, our ultimate goal is to create and provide a standard development environment, so that people who are developing on Solidity can still develop for Plasm Network without having to miss out on any new Ink contracts. And we want Ink contracts to be able to leverage existing libraries from Solidity. And this, right now, our scope is limited to EVM and Ink, but of course, in the future, we are looking into supporting more smart contract virtual machines. And yes, that will be the end of my presentation. Thank you, everyone. Thank you for questions.
Thank you so much, Hoon. That was great. So we have one question in here. What kind of privacy will Plasm use in the next level?
What kind of privacy?
Yeah.
Okay, so can you elaborate on that question? If the person can elaborate on that question, that'd be great. Don't understand what kind of privacy.
Yeah, Mark, if you're still there, we can wait a moment if you can elaborate on your question. And then the next question was just asking if the materials will be available for download. So I guess, would you be able to make your presentation available for people to view, and I can add it to the YouTube description?
Yes, it's in PowerPoint, so I'll have to find a way to upload that.
Yeah, like if you share it with me over email, I'm sure I can get it on Google Slides or something.
Oh, okay.
Yeah.
Okay, I'll send you the link.
Great. Just waiting for Mark to elaborate on his question. Just giving him a minute.
Okay, I think I see his chat. Smart contract plus privacy plus cross-chain equals the future of decentralized finance. So by privacy, I assume that he means Ziki Snark's privacy coin-esque kind of operations. We don't really have any specific protocols for ensuring privacy, but when it comes to decentralized identity, as a lot of people call it, we don't really have. We can't really say we have something that's special, since we're not really trying to claim that our network is specialized for that kind of stuff. However, having said that, our network, Plasm Network, is focused on empowering decentralized applications. And of course, if there are other privacy networks within the Polkadot network that can leverage XMP, then yes, our blockchain is able to use that as well. I hope that answers your question, Mark.
Great. And then another question just came in. Is there any progress in the development of smart contracts by WASM, libraries, etc.?
Well, this is really hard to answer, since we're not really focused mainly on developing WebAssembly contracts. So there are a lot of projects, or Solang that compile Solidity to WASM. Of course, Parity offers their own WASI compiler, and there's Hyperledger as well. I believe I forgot the name. The part of Hyperledger that uses WebAssembly as well. So yeah, in terms of progress, a lot of experimentation, I would say. Yes, a lot of experimentation from a lot of different community across different projects, but overall the results seems pretty good. It's just that it's quite hard for new developers to catch up to everything.
Yeah, there's a lot going on.
Mm-hmm.
Great. Well, that's it for the questions. Thank you so much, Hoon. It was great having you here. Very excited about what's going on. Oh, and we lost you. But yeah, thank you everyone for attending this Parity and Friends. We hope to see you at the next one. Keep your eye out on Twitter, on Crowdcast and Meetup when we'll announce the next one. So see you then. Thank you so much. Oh, you're back.
Okay. You pressed the wrong button there.
No worries. Well, we're signing off now. So thank you again.
Thank you everyone for having me. So much, Carol. I'll send you the email then.
Great. And we will add both those presentations to the YouTube video, which should be uploaded directly after this. So thanks, everyone.